I'm doing a video on modulation change I made to my Johnson 500. On this oscilloscope here, this is the voltage on the screen of the 4400. And this would be my RF output carrier, just for reference. So RF output and screen voltage. And what I'm going to do is I'm going to run it in a standard unmodified approach. So if I hit the microphone, you'll see that the screen voltage came up. The screen voltage at this point is a couple hundred volts. And as I'm modulating, you can see that the amplitude of the carrier doesn't really increase. So it's just not changing very much. I'm going to make one little change here. I'm going to add a capacitor between the plate voltage, which is modulated, and the screen voltage. Let me add that now. Okay. You see that the screen voltage is fully modulated now, and the carrier amplitude increases about 2 to 1, which is what you'd hope for. And when I take the change back off, I'm not good at whistling, the amplitude doesn't go up. Put the change back on, what's happening is I'm modulating the screen voltage on the 4400. Let me get this so everybody can see it. What's happening is the high voltage supply in the Johnson feeds a couple of resistors like 40K that goes over to the screen in the AM position. The VR tubes aren't used except in sideband. If I'm going to go to CW, they bypass the modulator. But anyway, this is the high voltage, about 2000 volts, 40K resistors, 45 milliamps or so being drawn on the screen grid. It results in a couple of hundred volts, 200, 300, 400 volts, depending on the drive on the RF signal. The modulator on AM is added into the plate voltage and goes around to the plate. However, when the plate's being modulated, the screen is basically tied to a DC power level, which is controlled by the power supply. It moves a little bit, but not very much. So what I've done is I've taken the modulation transformer's output, which is a modulated high voltage signal, and I added a capacitor between the plate and the screen. In this particular case, I used a 0.03. I wanted to keep the fidelity up a little bit. I started off with this capacitor, which is a 0.02, at 10,000 volts. But that's a big glass capacitor. And if you remember the movie This Island Earth, when the scientists ordered up some parts and got some wee little capacitors from the alien Exodus, or Exeter, this is what I'm using. This is a 0.01 microfarad at 10,000 volts. So I put a couple of those in parallel, which is what I did here. And when I connect the screen voltage, which is this lead, to the capacitor, I'm basically tying the capacitor between the plate and the screen. As you can see, it increases the ability to amplify the RF a great amount. And the reason for that is the 4400 is a tetrode, and as a result, the screen voltage controls its power level quite a bit. So by simply putting this capacitor back in the circuit between the plate modulated voltage and the screen, it gives me the ability to drive the thing a great deal better. You'll notice that the screen voltage is modulated quite a bit. And I apologize, I can't whistle. So by modulating the screen voltage, I get a great deal better amplitude modulated carrier. It's kicking up to a couple centimeters there, whereas the carrier is set for 1 centimeter. If I turn it down and adjust it for 1 centimeter, you'll see that the amplitude kicks up to the second graticule on the scope. And if I take the screen voltage off, carefully, hello, you'll see that the screen voltage pulls down, but it doesn't really increase. So we're not modulating the screen voltage. I think it's a clamp tube pulling it down. In any case, there you have it. A real simple, cute mod. If I increase the power level here, that's about 300 watts now. It definitely improves the punch on the signal. The screen voltage is modulated, which allows the tube to go to its full capacity. And right now, I'm about 300 watts. And the plate current is running along about 250 mils. Can't watch and whistle. So, there is a simple little mod if you're interested in doing it. Once again, I'll focus on the picture so you can stop on it. But it's nothing more than taking the plate voltage and adding a capacitor back to the screen and modulating the screen with the RF. Now, I made one mistake here, which I'm going to try to correct right now. Here's the RF choke in here. And this does not come from the plate. My mistake. The screen voltage has the capacitor going up to the modulated plate voltage before the RF choke. That was my mistake. I just corrected it. Engineering notes being what they are. So this capacitor is between the screen and the modulated high voltage section. Let me make my entry more legible. So there we have it. And I used a 0.03. A 0.01 will work, 0.02, 0.03. I just didn't want to get too crazy. But there you have it. And all we have to do is add that capacitor in there between the plate voltage and the screen, not between the plate. That would, of course, suck out all the RF. My mistake, sorry. So, if anybody's interested in trying it, I'm going to do that on my Valiant. I have to fix a VFO, a universal joint, one of those flexible couplings. And when I do that, I'm going to be making the same change to my Valiant. 73N4MQ.